Hi everyone. So today we have a very famous problem in LeetCode daily challenges, that is unique path 3. This is a hard level problem, but once you know the logic, you will say this should be a medium level problem. So let's quickly see what does this problem say. You are given m cross an integer array and grid where grid of ij could be 1, 2, 0, minus 1. And 1 that tell us that this is a starting position and 2 tell us that this is a ending position. So we have to start from one index where so we have to start from So we have to start from that particular position where we are getting a value 1, and we have to end that particular position where we are getting a value 2. And this 2 value is going to be unique in an array. After that we are going to have value 0. This tells us that this is a path which you can follow. And 1 minus 1 tells us that this is a path you can't follow. That means this is an obstacle. Now guys, here in example you can see that this empty block is nothing but a 0 value. You have everywhere 0. You can follow that particular path. But this red color box is nothing but a obstacle. So it is defined by minus 1, and this is a starting position which should be defined by 1, and here this flag is nothing but 2. We have to reach that particular position. All right, so let me just make it clear. Now guys, what does this say? Return the number of 4 directional bugs from starting square to ending square that walk every known obstacle square exactly once. That means you have to start from that particular position, you have to reach this particular position, but there is one condition: you have to follow every empty block, means known obstacle blocks. So here you can see that for reaching from this to this position, we can follow this particular path, which is using all the empty block. And also there's one more path you can see. We can also follow this path to reach this particular flag where all the empty blocks are getting used. So I hope you are getting this. We have to reach from starting position to beginning position by using all the empty blocks. Now guys, let's see the logic. We go to the question, we come to know what to find and how we can find it, that thing. Let's see this now. So here the logic would be nothing guys. We are going to use a DFS. Let me take a color better. All right. So we are going to use a DFS, and just to make it simple, forget about this condition that we have to use every known obstacle square. For now, just keep in mind that we have to reach from starting to beginning, and we can also face obstacles. So for this, we are going to use a DFS, which will take all the paths right now from there in 4 directions. It is not making any sense. So let's make it more readable. So we are at that particular index. Let me make a matrix. So this is a matrix we have, and we have to reach this particular position. And let give it a value 2, and this is value 1. So we have to start from this particular index to this particular index, and there are some obstacles. There can be like this is obstacles, and the obstacles defined by value minus 1. So let me write a minus 1, and everywhere you have 0, and here let's also keep a minus 1, 0, 0, 0, 0. So these are the matrix you are getting right now. Now we have to reach this particular 2 index location. How we can reach? So let me give a change. So guys, from this index location to reach this index location, we have a 4 choice. The 4 choices are: you can either move left side, you can either move right side, you can either move top, you can either move down side, right? But here you can see that we are getting some base condition. If you're moving a left side, that means you're going out of matrix. That could be a one base condition. If you're going upside, then also you can see you are getting out of matrix. That can also be base condition. And here you are not getting any out of matrix, so you can move downside, and also you can move right side. So we can use a DFS. After that we can say once we reach there, now we are going to say once you move this, you again don't go left side, you can't go upside because this is already being used. So we have to use a set as well. So we are going to use set, which is telling us that what are the indexes we have already been uses, so that we can't use this index again. Otherwise it will go in an infinite or recursion. Now guys, two things very clear that we are going to use a set, and also we are going to call our indexes 4 direction: left, right, top, bottom. All right, so now guys, let's see how we can get to this particular index. Once we are doing all these things, we are calling again this one index that you can move here as well. It will say that okay, I come to know minus 1, that means there is no path. Once you go to minus 1, that means you are going to return it. You're going to say there is no path exist because we can't move any direction with the minus 1. So okay, and once you know this minus 1 is not going to give us any path, so immediately we are going to stop that particular iteration over there only, and we will follow other paths. So here from 0 we can't go minus 1, but we can go right side with the 0. So we will reach here, and 0 also have 4 choice, but it can't go bottom, it can't go left side because it come from the left side and it can't use same indexes again. So it have a two choice to move right side or to move top side. So in the top side you can see I got 2. That means I got one path. So it will also gonna return as 0 because we are not reaching to this particular flag by combining all the zeros. We combine only 4 zeros right now. I know this is becoming very messy, but try to understand right now. Let's make it this index only. I'm going to say here only. You can see we can go anywhere in this array, but there may be some path which is coming to this flag without using these two empty blocks. So we are not going to return that particular path as a 1. We are going to return that particular path as a 0 because we are not getting a particular condition satisfy over here. So we can only return a 1 whenever we are reaching to this particular flag by combining all the empty blocks. So how we come to know this? There is also one condition we are going to use it. Whenever you are reaching at this particular flag, you have to tell us that you took how many blocks. So here I will say 1, 2, 3, 4, 5, 6, 7, 8, 9. I took 9 blocks to reach this particular flag. So that will tell us that okay, you took all the empty blocks. So we have to count also one time to check how many empty blocks do we have in this matrix. So let's quickly move to the code and see how we can count this and how we can use this function to tell us that whether we reach our particular flag by using all the condition or not. So here guys, you can see that first of all we have to count all the empty blocks. So for that I'm going to give variable name empty and emp. Initially it will be 0 because we don't have an empty block right now. Now we are going to traverse our list. So we are going to say for elements in grade and after that for value in elements means on each rows. Now we want to see whether value is equal to 0 or not. If it is 0, that means we have this empty block. So we'll say am plus equal to 1. All right, so once we done, we got a value which is telling us that how many empty blocks we have in our matrix. Now it's time to use a DFS. So for that, let me make a function. So what I'm going to do, I'm going to create a function here inside this only. I'm going to create a nested function. So here I will say define sol, and in this function I'm going to take a value row and column. Means this is going to tell us which row and column we are standing right now. And after that it is going to take a set as I have told you. So the name I'm going to give is visited. Now we are going to take one more thing. How many steps do we have taken right now? The last one is going to be emp. It's up to you if you want to take emp in your function or not, because this is a global variable now for this function and you can use it by using a non-local keyword. All right, now we are going to check first of all some condition. If row is less than 0 or column is less than 0, or we can say row is greater than or equal to length of our grid, or we can say that column is greater than or equal to length of our grid of 0. That basically we are saying that if row is less than 0, that means it is also out of matrix. Column is less than 0, let me write here 0, that is also out of matrix. Same goes for row greater than or equal to length of grid, that means it is also out of matrix. So we are checking all the condition where we are saying that whenever you can go out of bound. After that, one more condition that if row comma column in our is visited set, that means we can say that this is also we have already taken that particular index in this path. We can't take the same index again in the same path. So we are going to return on this condition as well. And one more condition we are going to take for grid of row and column is equal to -1. So if grid of row and column, that means the value of that particular index is equal to -1, that means that is obstacle and we can't follow that particular path. So we are going to return 0 on these condition. Now I hope you understood it. Once we clear this condition, that means all these conditions are false, then we can say that we are having a value which is 0 or either 2, because one value will already taken by this particular function whenever we call this first time. So we have to check it. If grid of row and column is equal to 2, that means we are at a final position, means we are at this particular flag. So for that we are going to return it 1. But wait, we are going to use some condition. That is, we have to check whether this particular path taken all the empty blocks or not. So for this we are going to say if step is equal to our emp means all the empty blocks, then we can say return 1. Otherwise we can say return 0. Now we are going to say step plus equal to 1. That means now we are taking one more step to reach to next particular state. Now we are going to move all the 4 directions. So for that, we are going to do solve, and after that row plus 1 time, column is visited, step and emp, and we haven't added that particular index in our set, so we have to add that also. So for that we are going to say is visited dot add row comma column. We are going to add in tuple, so I'm going to say row comma column. Okay, now we can call this function. So let me copy this. I'm going to paste it 4 times because we have 4 direction right now. So first time row will be 1, the second time row will be -1, After that, row will remain same, column plus 1. The next time column minus 1, row will remain same. All right. And guys, now one thing, once you complete this particular function, you have to also remove your index from a set, because next time we're going to take another path. Okay. Now guys, let's see how we can solve this particular problem by using this function. And one thing you must notice guys, I will point out whenever I call this function. Now guys, tell me when we will call this function. We can call this function only where that particular robot is standing, then only we can call that particular function, because that is our right starting index. Now we are going to use a loop for I in range length of grid. Basically it's going to tell us how many rows do we have. After that, for j in range length of grid of 0, that means it is going to tell us how many column do we have. So we are iterating every row, and after that we are iterating every column of that particular row, and we are telling if grid of I and j is equal to 1, that means that is a starting position. So we will call this function and we will directly return that as well. Solve, and let's call this. So we are going to give index row is I, j is column, and after that is visited is going to be an empty set right now, and then step value. So for now we don't have any step, we haven't taken a single step, so we'll say 0. And after that we will see emp, which is already we have calculated above all the empty blocks we have in our array. Alright, but before running this code, you must notice one thing, that this is have a 9 empty blocks in this example you can see, and we are going to check step is equal to m. But you know that to reach this particular index, we are getting one more step, right? So for reaching this particular flag, we are taking one more step, so we have to reduce step by one in the condition. Alright, so now you can also put a bracket for making a better visualization. So now guys, we reach at the last part where we have to add all the paths. So for adding all the path, what we can do, we can make a variable result 0, and here this also is going to return us some one path. This particular function also going to return some path. This one also means there are 4 possibilities that they can give us at least one path, right? So we are going to add all these number, and then if it is going to return a 1, that means there is a path exist. If it is going to return 0, that means there is no path exist. So I have added all the path. At the end I will say return result, means return all the path which is possible by starting from this particular index, row comma column. So let's quickly run this code and see whether we are getting right output or not. So here it is getting accepted, and let's see why other example test case. Accepted, submit the code, and guys you can see that it is accepted. So that's all in this video. I hope you understood the solution, and if you like this video, don't forget to hit the like button and subscribe my channel.